All right, so Mega Millions is a multi-state lottery played in most US states. As of this writing, the top cash prize was 1.05 billion, won by 4 people in Michigan. Players picked 5 different white-colored balls numbered 1 to 56 and 1 gold-colored mega ball numbered 1 to 46. So if the player wins, there's only one way that's going to happen. So our numerator is going to be 1, so we know that. But we have to figure out the denominator. Well, the denominator is going to be what? So we're going to choose numbers 1 through 56 for those 5 balls. So we have 56 balls, and we're going to choose 5 of them. Order, again, doesn't matter here. And then we're going to match 1 gold ball. And so there's going to be how many ways to do that? Well, there's going to be 46 possible ways to do that one. So we need to multiply those together. And when we do that, we get, all right, so clear that. So math, go over here, number 3. We have 56, and we're choosing 5 of those. And then we multiply that by the number of possible gold balls there, which is 46. So that's going to be our denominator, 1,757,11536. All right, so that's going to be 1,757,11536. So the probability of this event, which is winning, is 1 out of 1,757,11536. So pretty small probability that you're going to win that number. Okay, so that's going to be that probability. Well, what about this one? It says, okay, we're still doing this mega lottery. So it says they win a minimum of $150 by correctly matching 3 numbers drawn from the white balls and matching the number of the gold mega ball. What is the probability of winning this prize? All right, so now if we're matching 5, we have 5 possible and we're getting 3 of them. We have 5, we're choosing 3 of them correctly. Then we're going to multiply that by, well, how many were there total? There was 56 minus 5, so that's going to be 51C, and we're choosing how many left? 2. And we're going to get that gold ball, and there's only one way we can get the gold ball, and that's if we get it. Then that's going to give us our numerator. Well, guess what? We already know our denominator, and the denominator is this one. So the probability of this event is going to be, we have 1,757,11536. And so if we go over there and calculate that, clear that off. So we'll have math 3, and we have 5, choose 3 correctly, times, now we have math 3, 51, and we're choosing 2 of those, and we choose 1 ball, and we know that's 1, oops, times 1, redo. Then we get 12750 in the numerator. Now, if we take 12750 divided by, and we had our 1,757,11536, and see if it'll reduce it mathematically. It won't. So what we have to do is we just have to divide it by numbers. Well, if we divide that by 2, we're going to get, let's see, what's 12750 divided by 2, we get that number. And if we divide that one by 2, we're going to get 1,757,11536 divided by 2. We get that number. That looks like it's divisible by maybe, I don't know, let's see if it's divisible by 3. Oops, that one's divisible by 3. So 6,375 divisible by 3. That one's divisible by 3. That's 5, 6, 7, 8, 9, 10. That's not divisible. So I think our final number then is going to be this divided by this. So going back to here, what all did we have? We had to write this one down. That was 12,750. So that was 12,750. And we divided it by 2 and also a 3. So then we got 2125. And that one, I think, was the 29285,286. Or 56, sorry. That's a 5. I can't write what I'm typing. All right, so 56. And so then that would be our final answer. Again, it depends on if they want it as a decimal or not. This one, if you put it as a decimal, you know, you're going to get some times 10 to the negative value. And so it's going to be a lot of zeros. And so we're just going to leave it as a fraction in reduced form. All right. So let's stop with that. We'll come back for some more.